Fans, welcome to another installment of Spring Tips, in which we're going to look at Kafka Streams. In particular, we're going to look at Kafka Streams through the lens of Spring Cloud Stream. Now, in a previous video, we looked at Spring Cloud Stream, and in that video, we looked at Spring Cloud Stream and RabbitMQ. Now, broadly, Spring Cloud Stream is a framework that handles the connectivity of different messaging technologies and allows us to write code in terms of these sort of useful programming APIs. And the default sort of approach is to use the Spring framework messaging channel and messaging, message type. So those types are the core of the of Spring Cloud Stream. But that's no reason. There's no reason you couldn't use other bindings as well. And so today we're going to look at Spring Cloud Stream and Kafka Streams, which allows us to work with bindings from the Kafka Streams project. Now, we're going to build a simple analytics application, and we're going to use the Kafka support, the Spring Cloud Stream support, Lombok, and the web support. This will give us a new project which we can open up in our IDE, and this API is we're gonna build a simple analytics application that's gonna process events coming off of, let's say, some sort of imagined website or something like that. The data that we process, we're gonna then we're gonna need to be able to synthesize. We're gonna create some data, as though there was somebody actually clicking around on a website, for example. We're going to synthesize some data. In order to do that, we're going to use regular Spring Cloud Stream, and then, and only then, are we going to start to use Spring Cloud Stream and Kafka Streams to process that data, to work with that data. Okay. So we have two binders here in the same application. So Spring Cloud Stream binder Kafka Stream and Spring Cloud Stream Kafka, okay, binder Kafka. So I think that's the right one. Let's go ahead and make sure. Give it a second here to download. It's maybe it's S. Kafka Streams. That looks like it's the right version. So that with that in place, let's go ahead and build an application that writes data to our Kafka broker. Now, we should talk about Kafka a little bit here. We should understand what it is. Kafka is a message broker it's now an Apache project. It's very popular, especially among the internet darlings, the web giants, for a number of reasons. First of all, it's got a very, very flexible topology or domain model. It gives you a very flexible way to describe different systems, right? It can be used to do pub/sub or queue-to-queue or point-to-point rather messaging, but the thing that allows that kind of flexibility, partitions and groups, is generic, and so you can actually do some other things besides that as well. You can do some very interesting things. You can actually, for example, have point-to-point messaging that's also got multiple subscribers. For example, you can do you can scale up and do load balancing with the same primitive, right? Which is not necessarily always true of other messaging systems. Kafka, ultimately, if you ask people who work on Kafka what it is, whether it's a traditional enterprise messaging broker or something, they're more than likely going to tell you that it's a replicated log, right? It's actually a log. It's a log of records stored in a sequence, and there can be multiple messages in that sequence, of course, and they are put into a category, and that category is called a topic. So whereas in JMS or RabbitMQ or something, you have topics, queues, exchanges, etc. In Kafka, it's all just topic. And you put records into these categories called topics. These records are messages. We can think of them as messages. But within a topic, you can have multiple partitions, and these partitions mean that you can actually have, you have guarantees about ordering only within one partition. But the benefit of that is that I can have multiple consumers, each processing a different partition, but they're still working from the same topic, right? So they get linearizable processing that can also be done concurrently, which is very, very, very convenient, very, very convenient quality. Also, that replicated log is built in such a way that it's optimized for this kind of thing. It's optimized for large amounts of data. And so really what we're dealing with here is a database that you can treat like a FIFO, right? It's a database that has data that you can read in and out, right? Like a traditional message queue. This database the query time, the constant lookup time for messages in that database means that you can have 10 kilobytes of data, or you can have 10 terabytes of data. The seek time, the indexing time, for a particular record is constant. And that gives you some very, very, very useful properties, especially at scale and especially when dealing with constant load. Okay, so we've got now this simple application. What we're going to do is we're going to create an application that writes data to our Kafka broker. And I have Kafka running here in the background. I've got the Zookeeper instance, and then I started up Kafka, and you can just download a pre-built distribution of Kafka from the Apache website and just start them up. Okay, and I've got our new application. So we're going to build an application that produces data. So it's going to be we're going to write data of type page view, right? Page view event, or just let's just call it page view event, sure. And the page view event will contain information about who's making the request, about the page that they're viewing, and the duration of the view, right? How long were they on a given page? Now I'm going to use Lombok to create some, DTO-like things here, and we're going to create a page view event source. We're going to create a thing that gets called when the application starts up, and it's going to write data to the database when it starts up. It's going to have this callback. It's going to write data to this broker, actually, this Kafka broker. So we're going to say it's a component, and it, in turn, is going to use a regular Spring Cloud Stream binding. So again, here is where it pays to have paid attention to that last video. So we're just going to create an interface and define some channels, some output channels into which we can send messages. And the reason we have this sort of duality, this dual programming model, is because there is no way to write messages to a Kafka stream directly. A Kafka stream ultimately is just a topic, and the way you write messages to a Kafka stream or to a topic in Kafka is just to write messages to a topic, right? Kafka Streams is an API that you use when you're consuming data. So we're going to use message channels in traditional Spring Cloud Stream to write to Kafka, but then on the other side, we're going to use Kafka Streams to process the data. Okay, so let's see. String. We're going to call this. What are we going to call this? This is the. This is going to be the page views out channel. So we're going to page views out. Page views out. All right. So that's a little long, but it could just PV out. Let's do that. Okay. So page views out. Page views out, and I'm going to tell this class, I'm going to tell Spring rather, that I want to inject this type here in the constructor. Let's create a constructor, and we want to actually inject the analytics binding. So binding dot page views out. Now, in order for Spring Cloud Stream to know what to do with this binding type, we need to actually at analytics analytics binding dot class. We need to enable the binding here with that enable binding. So what Spring Cloud Stream is going to do is it's going to look at this interface. It's going to look at the names of these channels and whatever the types, whatever bindings we put in this interface, and it's going to look at the configuration, in the property file, which we'll look at in a second, and it's going to turn that into a connection to our broker. So let's do that. Let's go back to our configuration file here. We need to configure a few things generically. So let's do some defaults first of all. Defaults. I want these to be things that apply to every message that's sent into anywhere in our Spring Cloud Stream Kafka code. So Spring Cloud Stream Kafka Streams dot binder configuration dot commit. Oh, first of all, 3 commit dot interval dot ms equals 1,000. So we'll have a commit interval of 1 second. We want a default serialization key. So default key serializer. It's a serializer in Kafka parlance. So serializer is a serializer and deserializer. So serializer, deserializer. Okay, and you have to specify that for keys and values. Now, when we talk about keys and values in a Kafka context, every message has a key that's associated with that message, and it has a payload, which is the value. Now, Kafka doesn't care what those payloads are, or even what those keys are. You have to tell it that it's an array of bytes, or it's a string, or you should use JSON, or you should use Avro, which is actually a very common example of schema like Avro. So that's something that you're going to find you have to specify and worry about that a lot of different places when working with Kafka. So we're going to specify that up front because I don't like to have to remember that only after things are failing. Okay, so org Apache Kafka.common I don't even remember. Surdays. It's this class here. We're gonna reference a we're going to reference some Serdes from this factory class called Serdes. And we're going to use Serdes for the key. We're going to use string. There we are. String Serde. And for the value, we're going to use default.value.serde. We'll use that as well. All right. So there we go. There's our configuration, default configuration. And now for this particular thing, we're going to set up the binding for the page views out. Okay, so Spring Cloud Stream bindings. This is traditional. This would look very familiar. This is what you would have written even with RabbitMQ. So Spring Cloud Stream bindings dot. What do we call this? We call this interface PV out. Okay. Dot destination equals PVs. Okay, so I want to say page views, PV plural, right? And we also want to specify that we should have, we want to configure some things about the producer. In particular, we want to configure the header mode to be raw. All right, so there we go. That's the basis that we need for this. Let's see if that works. So we're going to now synthesize some data. So let's think about how we do this. I'm going to have some names here. Names equals arrays dot as list, and it'll be some names. It'll be JLong, sure, and pweb and Sobi Chakos, SCHACKO, Abilon, Ozirakuski, G. Russell. Okay, so we've got a few people here, sample names. Let's actually, M. Fisher, there we are. Some of the folks working on the messaging side of things, and Phil and I we don't need to be there. All right, good. So there's our names, and then there's some pages. Okay, so some pages on the website. So let's say it's the blog, sitemap, initializer. Because all good websites will have a Spring initializer, of course. News, colophon. Do people have website colophons? They should, really. And what else? What else do we want? About, sure. Okay, so we have some names now. Now what we're going to do is we're going to generate, we're going to run a thread that will periodically write some data to the message queue, right? So that thread is going to be run by a executor that will send a message using this runnable every 1 second. And there we go. There's our runnable. Now we need to actually save some data. So let's do that. Let's int. Let's see. We want to get a random name and a random page. So our page equals new random dot next int, and the number that we're going to spend the pages dot size, and that's a number. So let's turn that number into pages dot get, and then our names dot size. All right, so that looks like that'll be correct, right? So random page, random name, and we're going to send that data in a message, which we'll build here. So message builder dot with payload, and the payload, of course, is going to be an object of type page view event, right? So let's do that. New page view event, and we'll say that the name is random name, and the page is a random page, and the duration, in this case, just so we have something with which to work later, it will be either 10 or 1,000. Why? Why not? We want to have something that we can bifurcate the data with. So as long as it's greater than 10, we'll filter it out later. Okay, so I'm going to say page view event. I want to set a header, and that header is going to be the key. So I'm going to say Kafka headers dot message key, and the key in this case will be the page view event dot get user ID dot get bytes, and then we're going to build the record. Okay, so it'll give us an object that we can then send on that output channel. So now we can do that. So this the page views out dot send message, et voila. Okay, so there's our record, there's our data, there's everything that we expect. All right. Now let's go ahead and see what that gives us. Now I'm going to go ahead and wrap this in a try catch because it's quiet. If you don't catch any errors, you won't know about it. So let's just do that. Log.error, we need a logger. I guess we can use @log. And here, log.info, or sorry, error. No, we want the other one, don't we? Log for J, log extern, commons log. Logger, is it? This dot, what does this one actually give you? Whatever, we don't need it. Well, let's just do it the manual way here. Private final log equals log factory.getLog get class, voila. So now we have this log. It seems to be upset. Oh, wrong log. So reply to you and you. Goody. All right, so there's this. And now we say log.error e. All right. So that'll be if there's any encoding problems when sending this message out, we'll find it very quickly. All right. So we're going to schedule this thread every 1 second. We'll send out a new record with a random name and a random user and a random page. Let's see what happens. Not seeing any errors. I suppose I should have had a conformatory sort of message here. So log.info sent message.toString. Okay. Alrighty, so there's the message. It's sent. It's got a page view event. You can see it's got random names and users, random durations, etc. So now with that, we have a feed of data that we can then process. And we want to process this data using Kafka Streams. So again, we're using Kafka Streams. Kafka Streams is a processing API. It's a stream processing API. It can be used to do a lot of the same things that you would otherwise think about using things like Apache Storm or Spark or something like this. These are stream processing engines. But there's a big difference here. In order to use Kafka Streams, all you need is Kafka Streams, a library. It is just a library. It runs in the context of your application on your machine in the same node. It doesn't need a separate cluster. It doesn't need a separate processing topology. It doesn't need a custom serialization fabric for your workloads or whatever. It runs in your code. And so you can hang off Kafka Streams processing off the side of your sort of Spring Boot app, as we are here, and take advantage of that with no extra complications, right? It's just a library that's present on the class path, and it's a programming model. So it integrates very nicely with any other JVM code you've got. And that makes it invaluable. That means you can deploy this application easily. You can take this is just a regular Spring Boot application. So you can take this and, you connect this to Confluent Cloud, the hosted version of Apache Kafka from Confluent, the company behind Kafka. You could deploy this. You could get an account on Confluent Cloud, and then expose that to your application running on Cloud Foundry on Pivotal Web Services, for example. Right? You could you could deploy this easily to any public infrastructure, and it would be just fine. You don't have to worry about figuring out how to deploy Spark and all the networking requirements and all that stuff. This is just a regular Spring Boot application. There is state, of course, there's still state, but that state is kept in the broker. All you ever need to be able to run this code, to be able to process with Kafka Streams, is Kafka. That's it. Once you've figured out how to get that installed, which in the case of Confluent Cloud is super simple. Once you have that figured out, you're done. You're off to the races. The state is kept in between processing. It's kept in state stores inside of Kafka itself, or it's kept in topics, or it's kept in various nooks and crannies inside of your Kafka broker itself. And the replication of that state is done for you by, guess what, Kafka. So again, if you have Kafka, if you've figured out the recipe for scaling out, operationalizing, and working with Kafka, then you are done, right? No need for anything extra. And that state is useful, as we'll see here. So let's create a Spring Cloud Stream binding for the incoming messages. So the messages are going to be of type string, that's the user ID here, and the payload will be page view event. Okay, so I'm going to create a Kafka stream binder or binding for that. So it's at input, and I'm going to create a new variable here, page views in, pv in, page views in, and it'll be kstream and string page view event, page views in. All right. So there's your incoming message, your incoming Kafka stream. And this Kafka stream, as we'll see, is this is the API. You could create this yourself, right? There's that tedious configuration is being done for you by Spring Cloud Stream in this case, and the wiring we'll see for this is done external to this. So there's no mention of topics in this code. We just know we have a type object that we can work with. Let's do page views in. All right. So here we are, and on the incoming side, we're going to have basically the same thing as this. Same thing as this, but in reverse. So PV in, and it's a consumer, not a producer, whose headers shall be raw. All right. So that's I think all we need for that. Let's go ahead and see what happens. We need to actually process this data now. So we defined the binding, but the best part about this is that we can now use this binding to process the data. So let's create a Spring Cloud Stream processing sync. So page views event sync, okay, and this is going to be a stream listener public void process at input analytics binding dot class page views in, and we'll have kstream string page view event events. Okay. Let's do that. So now, private final log.factory, get log. Alrighty. So there's our incoming messages, events. And what we want to do is we want to take that data and work with it. So let's see, events dot, and we know that we're going to have data that's going to come in, and we want to filter it. First of all, I want to say, filter new predicate, or provide a predicate object there of type string and page view event. And by the way, these are the Kafka Streams types. These are not from Java 8, so this works in theoretically this works in older APIs, older JVMs. Although realistically, if you're using Spring Boot, you're in a Java 8 world. If you're using Spring Boot 2.0, which you all should be, by the way, now that it's out in GA, you're in the Java 8 plus world anyway. So we're going to say value.getDuration. Get duration is greater than, what do we say, 10 seconds. So there's our first bit, the lambda there. And if we've done that, then we want to map. I want to say that I want to map the, I'm going to repartition the data. So I have a stream of records. So each record will pass through this filter method. Then it'll be passed to this one. And here, I'm going to repartition the stream. I'm going to say, okay, the new key and value that you should manage is going to be oriented around the page and the count. So I'm going to say the value dot get page, and this I can just do 0. Who cares? Well, we don't actually even want the number. We don't even want the value anymore. What we care about is the count. So now we're going to create a count. Okay, so let's actually first of all clean this code up a bit here. Replace with lambda. Don't even need that. Good. And now we're going to store some data here. So we're going to say that we want to create a count of all the records in the stream. Okay. In order to create that count, I need to group by. I want to group by the key. In this case, I can group by using a custom key value mapper if I like, where the output type is the string or the payload that I want to use as a key. So here, it would be string, etc. So the key, the value, and all I want to do is just partition by the key. Well, there's a shortcut syntax for that. Of course, I could do a lambda, but there's even one that's even better. Just group by key. And now I want to store that count. And that count is stateful. Remember, what we're going to do is every time a message comes by, every time a message comes through this processing flow that has this key, whatever the key is, in this case, it's the page. So let's say that a message comes in and the page is initializer. Well, I want to keep a count of that. Where do I keep that? I don't want to keep it in the same node on the JVM process here itself. I'm going to keep that in the broker. So there's actually a whole persistent subsystem that is, it's exposed to you not just through this idea of a topic, but also through this idea of a materialized view. So I want to keep that count and then increment the number. So I'm going to say materialized as, and I'll give it a name. I'll give it a string, page views, page count materialized view. All right, so I'm going to use analytics binding there. Create that constant page count materialized views. All right, MV, whatever. So we don't need to do anything to configure the materialized view, but that's nice because we'll find out later that we can actually interrogate this materialized view. We can actually query it as independent of this messaging abstraction that Kafka gives you. So that count is now, if you look at the return value that comes from that count call, you get something called a K table, and a K table is a different thing than a K stream. A K stream is a continuous sequence of messages, and some may be the same exact, they may have the same data and key as previous messages, but it doesn't matter. It's a continuous, ongoing, sort of unbounded stream. Whereas a K table is, it's always going to be the latest value of a given key, right? So a K stream will have maybe 5 or 10 messages with the same key. Maybe they have different values, maybe they don't, but you'll be able to, if you use the K stream, you'll be able to get access to all 10 of those messages with the same key. With a K table, you'd have one entry for the key and then the latest observed value for that key, right? So this is like a database table. It's a change log versus the sequence of events that led to that change. And so we can actually process things with this K table, and that's interesting in of itself. But what I actually want to do is I want to take this data, which is coming from a K table, and turn it into a stream, and then send those results to another topic so that we can then, on the other side, process them as a K table in another piece of code. Now, there's a lot of, the distinction here is very interesting. The distinction between a K stream and a K table is one of the reasons that Kafka Streams is so powerful. That duality leads to a lot of really, really powerful opportunities. In Kafka Streams, things can go from one to the other very fluidly. So I can have a Kafka stream that shows me all the events that led to something, and I can have a table that shows me the change, the final values for those things as recorded. Well, I can also then turn that list of final values into events, right? So I can actually I can do things like event sourcing very, very naturally in this way. You might have, for example, a Kafka stream that has all of the people that have ever flown a flight, right? Whereas a Kafka table could show you how many people have flown over a year, for example, or over a month, to different countries. See what I'm saying? So you could say, given a country, show me the count of people that have gone to that country. And this brings us to another point here. I have shown you a count here, and that count is an absolute number. In this case, this K table is an absolute number. It's just going to be, for every message ever seen, show me the count. But maybe I don't want that. Maybe I want to actually get a count for everything in the last hour, right? And I can actually do that. I can say windowed by time windows dot of, let's say, 1,000 milliseconds, right? A second, or 60 seconds, a minute. So now I've got a windowed table, right? And that's actually slightly different, right? You can see it's a K table of windowed of long. So it'll show me, if I query this, if I pull this data out the other side, it'll actually show me time gaps. It'll show me, from this hour to this hour, and then from this hour to this hour, and then this hour to this hour. That's the number that you'll get. You'll get an array of windowed with keys, and then you'll be able to pull out the value for that window, for that particular time group. And this is very convenient because you can do things like, you can bucket data. You can say, okay, this is the processing time, right? This is the time that, or rather, this is the event time. This is the event time that this thing happened in the real world, and I want to be able to figure out what that looks like later on, retroactively, in terms of, I can run statistics over it. I can process that data. I can use that data to figure out how often things are happening. And that state is also something that you have to keep somewhere, and this is where it's nice to have this sort of unified persistence approach, right? So you could even, these K tables, you could originate K tables by, you could actually create a K table by reading the records from a database. It might be even a fixed database, but you can put it into a K table. And then the best part is once you have these K tables and they're, they're established, you can join K tables. So I can have a K table that join on another K table, left join, outer join, etc. And same thing for K stream. So I don't have a K stream here. Oh, I do actually. I can say events dot join K table, and that would join the events on the left with the records in the K table on the right by their key. So as long as the K table has the same key as the one on the events, then they will be matched up, and I'll get the result. This is, let's see, K table. This is a silly example, but if I did that, what do I have here? K table, etc. And then you provide a new value joiner. So new value joiner, or even better yet, just do left join K table and new value joiner, and so on. So the result is you get a stream of whatever the result is, and this is the the value on the left and the value on the right, and I'm supposed to aggregate them in some way. And of course, I might have nulls. A left join, it means I have one of everything on the left, but I might have some missing matches on the right, for example. So just like a SQL database, just like a relational database, you've worked with these kinds of idioms before. Now you have full control, and the resulting stream. Let's say this is a string. Okay, let's say somehow I got a string out of that. I can say is a stream, a resulting stream of string, or maybe a better example is a date or something. I mean, so you can understand what's happening here. Date, right? So now this becomes a string to date match, which is really powerful, right? Now you can do some these are both moving targets, right? They're both continually updating, but now you have the ability to, in memory or in flight, do these joins between two different disparate data sets. You can do correlation. You can say, okay, well, first of all, here's all the people that have clicked on a particular page, and then over here, here's a K table that shows you the related information about that page, for example, or people. You can break down the user information. Maybe I've got user information here. I can say, okay, here's the page view impressions, and then I can join that to a list of all the geography distributions for different people, different users. I can say, in San Francisco, and this person's in that city, and I now arrange so that both of them join on the user ID, and I can find out how many people visit a particular page from given regions, for example. Right? You can do some very, very sophisticated things by taking advantage of that joining capability and the fact that you've got these K tables versus streams, but they are ultimately both backed by topics. Okay, so what we want to do is we want to take this data and turn it into a stream, and send that stream back to send the results of that stream to another topic. So I'm going to say K stream of string long, and we're going to say at send to, and it's going to be page counts out. All right, so analytics binding dot page count out. Page count out. Create that constant PC out, and we'll do in because we know that's coming. All right, so going back to the code here, we need to change our processor. So there's this KStream, and we need to return the data. So return like that. All right. Maybe that's a little easier to read. There you go. That's a little bit better. So we're saying process the data coming in from the page views. That's going to give us one kind of stream. We're going to turn that into another kind of stream. In this case, it's a stream of pages to counts, right? And it's the total count. And then I'm turning that list of that. I'm turning that table into a stream. So now I'm going to get there's a new topic. This new topic will have all the keys, and anytime the key changes, I'll get a new record. Right? So if the key is, the initializer, and the first value is 1, I'll get a new record for 1. And then if somebody sets that record to be, if the count increases to 2, then I'll get a new record for that, etc. But I won't get I won't get to every single event. I'll just get the changes, right? for counts. All right, so there's that. Now, we need to actually configure this this output channel, this output binding here. So I'm forwarding the message here. This is a processor. Really, actually, I should call this a processor in messaging parlance. Page view event processor, and we're going to send this to page count out. And the page count out binding is going to be just that. It's going to be a case stream, but we're treating it like a it's a case stream that we're going to send out. So output and page count out case stream string long page count out. All right, so there's that. There's a page count out, and now we are going to process that data. So we want to process that data coming in. So we're going to also have a input k table. So input page count in, and here we're going to define a k table of type string to long. So page count in. All right. So now we need to configure the page counts for out and in. So let's do that in our config file. So page counts out, and let's see, page counts in. And for the config, this gets a little bit more tedious. We have to actually specify a fair amount of configuration here, but we do get a lot of benefits for that. So at least we know it's there's a gain to that. It's not something that we want miring our code with complexity, so much better to have it as a configuration parameter. So here we're going to say Spring Cloud Stream bindings dot, what did we say? We called it PC out dot destination equals PCs. Let's just call it that. Going with a theme here, and the PC out dot producer dot use native encoding equals true. And then we need to specify the serialization for the key and the value for this particular channel. So Spring, we can just copy this basic idea up here, this prefix. All right. So Spring Cloud Stream binder, Spring Cloud Stream Kafka.streams.binder dot bindings dot PC out dot producer dot value serde and key serde. So the key serde is going to be very similar to this. It's going to be a string serde. But here we're going to use a long serde. All right. So there's the key and the value serde. And we need to do the same thing on the other side as well. It'll probably still work even if I don't bother, but we do need to get this done, so might as well do it now. The main bits, the main difference here, of course, it's the same destination, right? So we do, that's fine. PC out, PC in, and PC in again. And here, we also need a group, an exclusive consumer group. So I'm going to say that the group is going to be called just PCS. That's our problem. And here I'm going to specify PC in, consumer, key serde, etc. All right, so that gives us a destination. We're using native encoding. We want to specify the header mode, of course. So header mode. Whoops, wrong one. I want to specify this one. Is that right? Spring Cloud Streams. No, I want to specify this one. So consumer dot header mode equals raw, and here this is a consumer as well because it's the incoming data. So we've got consumers everywhere equals true, right? Let's see, is that all? That's a 1, 2, 3, 4, 5, 6. So that looks about right. I think that's about right. That's all we need to make this work. Content type. Maybe we should specify the content type. I'm never really sure. Content type is equal to application JSON. Sure. Okay. Now there we go. We have the updated configuration we now have a page count in and out. We have a page views in and out. Let's move that up here to be with its related thing. Page views, page counts, output page count out, input page count in. And that's it. That's the configuration. So now, if this goes correctly, we should now be able to write a bit of code that processes the data coming from the K table, right? So add component, public, static class, page count sync, all right? And here, we're going to have a stream listener, and we'll say analytics binding dot page count in. We want to public void process at input, and it'll be a K table string to long counts. Ready? So there's this. Now we've got counts, and here in the counts section, we're going to just visit the data. So we can say to stream. We're going to turn it from a table to a stream, and then we're going to visit each one using the new for each action, and we're going to log it out. Okay, so we'll just log out the data just to confirm what we think is happening. So final log equals log factory dot get log. Alrighty, and let's just log everything out. Key plus value. So there's this. Let's see what we get. Is that going to work? That should work. That seems simple enough. We have now page count sync that's processing the data that's going to be sent from this processing thing. So the data is going to come in. It's going to be sent out from this processor. It'll be sent to the page count out topic, and we can see that the page count out topic is pointing to PCS. That input, then on the other side, we're going to have an input that processes the data from PCS. Now, I'm doing this all in the same application, but as you can imagine, there is no reason that this could not be different sinks and sources in different microservices, different applications, each focused on one particular aspect of the application. All right, so that should be it. Let's see if that works. We're going to go ahead and just get that running. Sending a message, good. Hopefully it's going to work here. Is there an error in here somewhere? There we go, look at that. Page count sync is now getting data. So you can see these are the number of messages that have been seen for a particular page being reflected here in the console. Okay, so that's working, and we're periodically getting data from that table, and it's showing us the aggregates. Now, I want to be able to inspect this data, right? It's nice that I have this ability to then corral this data, but actually, remember what we said. That data is also being written to a state store, right? That's this thing right here. That state store is queryable. So let's create a REST endpoint that surfaces that information. So at REST controller, public static class count REST controller. All right, and I'm going to inject the queryable store registry and create a constructor argument here. Create an endpoint, get mapping. I'm going to call this the counts endpoint for lack of a better name, and it'll just be just that. It'll be counts. And we'll come back to that in a second. Map of string long count equals new hash map. All right, reformat. Okay, so we've got now the counts, and what I'm going to do is I'm going to use that registry. I'm going to say this.registry.get queryable store, and I'm going to use the name that we created in the binding. So page count analytics bindings.page count mv, and the kind of data I want back, I have to specify a queryable store type. The kind of data I want back is a key value store, though that said, there are window stores, for example, that we could, that correspond to the data that you would get if we had used the window operator before. In this case, we just have simple keys and values, so we'll pull that back out. All right, so queryable store, all right? And the data that's coming back is it's a key value like Redis of string to long, right? So there's this. And now I'm going to visit that data. I'm going to say queryable store dot all. That'll give me an iterator. And I'm going to visit all the data. Well, all that has next, all dot next, and we'll store that. Okay, so we're going to add this to a counts dot directory value dot key value dot value, and we'll return counts. Goody. So there's our simple map. We're just iterating over the data, and I'm going to surface that as a REST endpoint that somebody can then hit while processing is happening to see where things stand. So let's see what that looks like. All right, we got some data being processed. Things are moving along. It's being moved across the wire from one node to another, and every now and then we get some data there. Now we go to local host 8080/counts, and we get this JSON that shows us the updating counts. Right, the data here is slowly but steadily updating to reflect what we're seeing in that table. All right, so we've looked at just a few things here. We've looked at Spring Cloud Stream and Kafka, although that was just a quick revisitation of or a review of what we looked at before when we talked about Spring Cloud Stream and RabbitMQ. We looked at basic production of data into Kafka. We talked about what Kafka itself is. It's a very interesting technology, and we're seeing it being used more and more increasingly. It's already powering thousands of different websites. I remember this is now, it's got to be a couple years now, at least a couple years. There was a big story where Netflix was using Kafka, and they were doing something like 1 billion events a day or something like that, something crazy, right? Some crazy amount of data passing through their Kafka systems, no problem. And that was years ago. That was at least 2 years ago, maybe more. So that's one thing that we looked at. We looked at Spring Cloud Stream and Kafka. Then we looked at the Kafka Stream support, right? So the Kafka Stream support is the key of what we're talking about here. It's the essence of what we wanted to focus on today. It's the thing that allows us to write data and then process it, to stream over it. And that stream processing, as we say, is, it's just embedded in our Spring Boot application. You saw that there's nothing special about this. This is just a so-called fat jar. I can deploy it to Cloud Foundry or to any other, or to Pivotal, the Pivotal Kubernetes service, PKS. We can deploy it to that. I mean, whatever you want. You can deploy these apps into a cloud just like you would in any other Spring Boot application. And the Kafka Stream support here is using Kafka as the store, and so that's where really all the magic is happening. And you do have to be, since you are dealing with a store, and since there is serialization involved, you'll see that that's kind of front and center in a lot of the stuff that we've had to do here. Anywhere you see the word serde, that's the surfacing of something that is related to the fact that you're persisting data. Remember, ultimately, Kafka doesn't care. It just sees a bunch of bytes. It doesn't care about what the contents of those bytes are necessarily. And then finally, or rather, going on further, we saw that you can do some, very, very interesting kind of routing with Spring Cloud Stream. So here, I've got an input k-stream of string to page view event, and then it was a processor, so I created a k-stream of string to long. I used just one value here, but there's no reason that I couldn't, for example, send this to multiple topics, actually. So the send to is actually an array. So if I wanted to, I could send this data to multiple destinations, to multiple topics. And this is great if you're doing event sourcing as well. I can actually say, okay, this is the state of the system, but I want other people who are interested in updating themselves based on that state to be aware of it, for example. So you can do interesting things there. We looked at the possibility for joining data, which I think is one of the most powerful opportunities that you have here with Kafka Streams, is the ability to take two different sets of data and to merge them real time as you're processing and to arrive at synthesized data. We also looked at windowing, which is another really amazing feature that you can do here in Kafka Streams, and that state is kept somewhere. It's kept in the broker. And so if you compare this to, this looks very familiar to the Spring Cloud Stream support for Reactor, right? So you get publishers and so on. But that state for a Reactor it's in memory. It's in the Java code. It's in the Java process. So if you have any state that needs to be replicated across nodes, there's no way to do that. Kafka Streams give you the ability to scale this across as many nodes as you want and still get a consistent, picture of all what's being processed, what hasn't, and so on. So all of that state management is done for you. We looked at K-tables. Like I said, K-tables are slightly different beasts, but there is a duality. It's very easy for a K-stream to become a K-table and for a K-table to become a K-stream. And you can see that here, right? I've got a K-table becoming a stream and so on, vice versa. Then we looked at the state store, right? The state store, I just used one of those examples here, but the table, that we are creating results in state being written somewhere, and that state is interrogatable. And so you can actually look at that state like a database. It becomes a key value store. That's really, really powerful. So now I can actually have as long as I can coerce all of my different disparate sets of data into a K-table or a K-stream, then I can process it here in this code very simply and massage it and so on. And I can do so independent of scale, right? I mean, I can scale to, like we said, in the case of Netflix, billions of events per day, and this would still be the same fundamental mechanism. Now, when we use Spring Cloud Streams and Kafka Streams, we get a lot of benefits. We're building, of course, on top of the Spring Boot auto configuration. So remember, we have the Spring for Kafka project. That's the basis for all the auto configuration here. That's the thing that gives you the auto configuration for your Kafka template, for example, and your consumers and so on. So I can say spring.kafka.bootstrap servers equals foo bar. I can point it to the producer information, client ID, the serializers, all that stuff I can specify at this most basic of levels. And this is the kind of stuff that you'd have to remember to set when you use the Confluent Cloud hosted Kafka, for example, right? That's in Spring Boot, and that builds on the Spring for Kafka project, Spring for Apache Kafka project. Then we have Spring Cloud, we have Spring Integration and Kafka. So Spring Integration and Kafka, there's adapters, inbound and outbound adapters for Spring Integration. And then we have the Spring Cloud Stream Kafka support, which is what we're looking at here. And then we have the Spring Cloud Stream Kafka Stream support. So it can be a little dizzying, but you can see here that at the highest level, using the most abstract of those APIs, the Spring Cloud Stream Kafka Streams support, we get a lot of power, right? Really, really convenient processing technology. All right. We also looked ever so briefly at the topology. We talked about the topology of a Kafka system, but it's really important to understand that we're taking advantage of the fact that there are partitions here and that there are groups. So you saw at one point I had to use a group, and that allows multiple consumers to be listeners to other streams. That's an important part. So you're going to find when you dive into Kafka that you need to really care about partitions, and you need to care about the consumer, right? There is the concept of the producer and the consumer ultimately contains it knows about the offset. It knows about how many records into that sequential log of records it has read, and it can control that. It can seek to the latest offset and just start from the new ones, start processing and draining the queue from the new ones, or it can go back to the very first one and replay every single existing message. And Kafka itself is a log, so it's meant to store data on file system. Like I said, it can be 10 kilobytes or 10 terabytes. It doesn't matter, right? So you have a lot of power here that make it a very, very reliable system for large amounts of data, especially large amounts of data that needs to be processed in real time. And of course, if you're doing it in terms of Spring Boot, it couldn't get simpler. All right, my friends, with that, thank you so very much, and we'll see you next time.